So you understand now that the probability of making a type 1 error, if the null hypothesis is true, is alpha percent of the time. If there's nothing going on, nothing at all going on in the real world, and you do a statistical test, there's a 5% chance that you're going to run around saying, hey, there's something going on in the round. There's something going on out there. This is a type 1 error. Now, you never actually know when you made one. If you find something weird and run out there and start reporting it, other people will be like, that's kind of weird. Let me try to replicate that study. And they would replicate it or get close to it. And then eventually there'll be more evidence that say, wait, there is nothing going on out there. And then you kind of look like a jerk because you were the one who originally found it. But if you appropriately acknowledge the way you play this game, you're going to make some type 1 errors. The problem is you don't know when. So I'll show you some type 1 error examples, but I have to add on this slide, are they really type 1 errors? We don't know. A student brought me this study in an epidemiology course. We were looking at the different study designs, case control, cohort study, and so on. This was a case control study where people who had testicle cancer were asked about their recreational drug use. And those responses were compared to people who did not have testicle cancer and the controls. And then they were looked to see if recreational drug use differ between the two groups. Zelda, are you on today? Is your mic on?
I'm here.
Tell me some recreational drugs you would ask about if you wanted to do a study on whether they were related to a certain cancer. What drugs would you ask people about?
Okay. Marijuana, heroin, cocaine, ecstasy.
Oh, well, I could think of a lot more than that. LSD, barbiturates, PCP, crocodile, MDMA, vaping, cigarettes, alcohol, poppers, crack. You said coke. We use crack, meth. Sorry, that was a lot more than you. I just thought of 15 off the top of my head, right? Now, if you tested enough drugs, what are you going to find eventually? Something. What drugs would they test? Here we see tobacco, alcohol, Quaaludes, LSD, mushroom. I forgot all these. Barbiturates. Look at all of these drugs that they tested. And not only did they test all of these drugs, but they stratified by different types of cancer. And they looked at when they used it, how long they used it, how often they used it. This is a lot of statistical tests. Even if there's no relationship between any of these drugs and this outcome, what are you going to find? Something. That title of this paper, let me just go back, is there's a really interesting word right in the middle of the title of that paper. I'm not sure, not risk. The interesting word is this. I'm not sure, based on what I just read about the study, that I'm confirming anything. I think they threw a bunch of stuff at the wall and looked at what stuck. And one of them was marijuana. Now, you might want to say, this is hypothesis generating. Is this the first study that does something like this? Okay, so they did that. This is the first report. And then they come up with some sort of mechanism. But for me, I don't think that really, how can you confirm anything if you're the first person to say it? That doesn't make any sense to me. So to me, this smells like a type 1 error. Now, what has happened since this paper was published in 2012? Well, I'll let you look that up and see if you think this was a type 1 error or not. This is an interesting study. This was a study about epigenetics. Epigenetics changes, epi means upon, changes that happen to the genome. Watson and Crick and Rosalind Franklin would freak out if they knew about epigenetics, that a lot of this stuff that happens to us is not necessarily the genes, but it's things that happen to it, histones and methylation. What your mom's mom ate when she was pregnant with your mom's mom affects you and your health today. That's true. You can look it up. This was a study about things that happen in utero to the mother. Does it affect kids later on in life, their risk for asthma? And they were thinking, these researchers, what is a stressful thing that can happen to a woman when she's pregnant with a kid? These data come from one of the Scandinavian countries that have all these interesting linked databases on health and economic information. And you can look anyone up by their numbers. And they said, I bet if you were pregnant and somebody close to you died, that would be pretty stressful. Loss of a close relative. So they were able to look at pregnant women, and they were able to look at, while they were pregnant, did another one of their children die? Did one of their parents die? Did their spouse die? And these research were really careful. If a woman who was pregnant, if her husband died, but she was the one who murdered him, they excluded them from the study. So they really good. This is really careful sort of stuff. This is not some Mickey Mouse little thing. And then they looked at those kids, and they looked at those kids years and years and years later and looked to see if the kids had asthma or not. And then they calculated this thing called a hazard ratio. It's just basically a statistic, is how much does it increase your risk? And you've studied that one in epidemiology. And then they stratified all the data based on all of these things. When did the death occur? Whom was the person that died? Was it traumatic? Was it natural? Are they boys? They tested a million different things. And if you test a million different things, guess what you're going to find? Something. You're going to find something. So there's a significant p-value in here. Here's one. That basically says if you're a boy and during the second trimester in womb, your mom lost someone who was close relative, you are 55% more likely to have asthma when you're older relative to that. Now, why only boys and not girls? Why only during the second trimester and not? Well, you might even start to think about some sort of mechanism. Well, if you're a boy, there's this testosterone, and that's the time at which the lung forms, and blah, blah. You can make up a story. I'm sure you could to explain it. You're good at making up stories. I think that's a type 1 error. These examples I found. I don't know what they are. So here's a study by Shaolin and others. Extreme summer temperature and birth defects. So it's a study of kids with a condition compared to kids without, and they look to see, is extreme summer temperature a risk factor? And they tested. I find these examples. At Tufts, there's a building, and it's in the library. They have a bunch of these little things. They look like magazines, but there's no pictures in them. It's mostly just like articles. Those are called journals. I like to flip through these physical journals. And when I see a table like this, I think, maybe a type 1 error. So in this whole thing here, there's no relationship between temperature and birth defects, except this little random thing right here that pops up. And if you look at it, see how that confidence interval goes from 1 to 1.37? This is an odds ratio. So in a ratio, again, we saw the null value would be 1. To me, I think this is probably a type 1 error. There are some other statistically significant things in here. And the other ones, they all pop up related to the eye. So this makes me think maybe there's something going on there. I see things that are a little consistent. I might be able to come up with a mechanism about how the eye forms. Is it a type 1 error? I don't know. I really don't know. If you look at enough data, you will find things. I've heard if you beat your data enough, they will confess. This awesome website is called Spurious Correlations, and they just show you that if you look around, you will see coincidences. There's a great physicist, great scientific writer named Richard Feynman, who started a talk once, and he said, oh my God, I saw the most incredible license plate today, RYM472. What's the chance of that? A student sent me this one, and I included it in my slides for a few years. It was studies about people who had the plague and things that they had done, and they were looking at, you might not be able to read this, selected dog associated exposures with relationship to the plague. And there's one thing in this whole thing that's significant, and it says if you sleep in bed with your dog, you are more likely to get the plague than people who don't. It just sounded really dumb to me. And I said, this is a great example of a type 1 error. And then I had a vet student who was like, I think that's real. I'll leave it up to you to go poke around. Is this real or is it a type 1 error? So always be careful. When you see tons and tons of comparisons, something will pop up. It should be framed as, hey, I did tons and tons of comparisons. Something popped up. That's interesting. I have some hypotheses. Future research is needed, and so on. Frame it appropriately. Instead of acting as if you tested a ton of things, you can't act as if you only tested one thing when you actually tested a ton of things. The p-value is about one test. And if you cross that field enough, eventually you will get struck by lightning.